Hello everyone. My name is Elena Papadopoulou, and I'm from Innovact. I am very happy to welcome you in today's webinar named Human-Centered Remote Maintenance and Asset Management. So before we officially dive into our webinar, please, I will let you know that this webinar is being recorded so that we can share all the insights on our website and on our YouTube channel and of course on our social media. I would like also to welcome Joshua Barbian from SCHMIDT HAENSCH and Matthias Horner from Mentastic, who will show us how the XR5.0 project brings AI and smart tech directly to everyday industrial work. Following our speakers, I will be leading a quick live survey. So there we will need your participation and your feedback, of course. And in the end, we will have a 5-minute open discussion. So Matthias, the floor is yours.
Thank you, Elena. And welcome everyone to today's webinar. The topic is, as Elena already mentioned, human-centered remote maintenance and asset management. It's a topic that evolved around pilot number 2 of the XR5.0 research project. It's a collaborative effort between SCHMIDT HAENSCH and Mentastic. And Joshua also joined us from SCHMIDT HAENSCH. I think he's head of product management right now. Please correct me if I'm wrong. And I'm also a product manager from Mentastic. Today's agenda will be divided into 5 steps. We will first give a short company introduction of our companies, and then we talk about the motivation of our pilot, the webinar, and the project goals of XR5.0. We will discuss our approach that we are following with an AI assistant and mixed reality remote support. So how natural language reporting can create guided troubleshootings and which use cases will be enabled by AI and mixed reality. This is followed by an adoption guardrail that we crafted and some advice that we want to hand over to you, how we will keep the future with AI human-centered, safe, and useful. And this session will be ended by a survey. We are very interested to hear your perspective on AI, mixed reality, and the future of maintenance. And now I will hand over to Joshua to introduce SCHMIDT HAENSCH.
Yes, thank you, Matthias. Hello, everyone. Also welcome from my side to today's webinar. My name is Joshua Barbian. I'm the head of product management at the company SCHMIDT HAENSCH. The company is a very old German medium-sized family-owned company founded in the year of 1864 in Berlin by those two gentlemen, Franz Schmidt and Hermann Haensch. And if Matthias is so kind and move to the next slide, we'll see a little bit what we do. So since the very beginning of the founding of this company, SCHMIDT HAENSCH has developed optoelectronic analytical instruments that you can nowadays find in laboratories all over the world, in the food and beverage sector, pharmaceutical sector, chemical sector, petrochemical sector, metalwork sector, really almost in every industry in the world. Besides the equipment for the laboratory instrumentation, we also manufacture inline sensors, which mainly base on the same technology as the laboratory systems, but they are used to be installed directly in pipe systems or in tank systems. And SCHMIDT HAENSCH is operating from Berlin. We are developing, manufacturing, and vending all of this equipment from our headquarters in Berlin. And Matthias, if you go to the next slide. And from Berlin, we're really operating worldwide. Here we see my father and current owner of this company in 5th generation. We are currently in transition to the 6th generation of family ownership. And even though we're only a medium-sized company in Berlin, we operate together with a lot of distributors, service engineers all over the world, so that we are able to operate in more than 100 countries. And nowadays we can count more than 100,000 customers all over the world. For us, partnership with local companies in different countries of the world is very important. We always like to work together with distributors and service partners, and this is also a reason why we joined this project. For us, the whole topic about knowledge transfer and being able to be everywhere in the world at the same time, even though our main team, our headquarters on Berlin, is very important. So the technologies that we investigated in the XR5.0 project, where we joined as an industrial end user. This means we are not the ones that develop the software solutions that we are using, but we use the software solutions provided by, in this case, Haentastic, to test this directly in the field and see how it can bring value to a medium-sized company like ours, who is working with machines, analytical instruments. And if you continue to the next slide, Matthias, you'll just see a few of our references. We're really present in all kind of different industries, very, very known in the sugar industry, but also in the pharmaceutical industry, chemical industry, and so on. I think a lot of those companies will be familiar with you. And this is all about company context. I hope you get an idea about what kind of company we are now, as this will be important to understand our use case. I'll hand over to our excellent solution providers from Haentastic. So Matthias can also give a little overview about the company.
Thank you. Yes, we are Haentastic. We provide a computerized maintenance management system, short CMMS. And it's a software platform for technicians, maintenance planner, and head of productions. The company was founded in 2016, named Oculavis as a spin-off from the Fraunhofer Institute for Production and Technology. In 2025, so last year, we rebranded to Haentastic because we are not a glasses provider, which lots of customers or interested leads thought we were providing smart glasses, which we don't. So we rebranded to a more maintenance sounding name called Haentastic. And since then, yeah, we focus more on building a CMMS software. We have more than 120 customers. We are very compliant with an ISO 27001 certificate. And currently we have a team of about 60 employees, and our current annual recurring revenue is around 4.8 million euros. The platform that we build and offer is an AI-powered and collaborative CMMS. We have modules that allow the user troubleshoot ticketing, create work orders, and manage these and distribute alongside the maintenance team. You can showcase and populate the platform with checklists, instructions for SOPs. You can use it to manage your assets, your factory locations, and it's also used for spare parts management. The platform itself integrates itself to several third-party providers and ERPs like SAP, Teams, and Salesforce, if I'm not wrong. And lastly, the platform offers also some mixed reality integrations with some smart glasses and augmented reality glasses that allows spatial chat overlays, spatial video calls, and annotations on those video streams. And currently we focus a lot on building AI agents to make the interface and the platform more accessible, which can be enabled by AI. So we are talking about voice enabling with voice to ticket, for example, and faster information retrieval done with retrieval augmented generation and large language models. And all these technical buzzwords I'm mentioning now will be covered later in the presentation. So the motivation of our pilot basically is derived from artificial intelligence and mixed reality, and how these two combined can reach the technicians on the shop floor. So technicians on the shop floor often struggle with downtime, knowledge gaps, and technical complexity. And these basically always meet right at the shop floor at the asset. And if there is a troubleshoot case that has to be solved, the technician needs the information and the instructions in this second and not an hour later or 2 hours later or next week. So the faster it gets to the technician, the faster the problem is solved and the machine is up and running again. Because as we all know, each minute costs the operator and the company money. And exactly here is a use case that is enabled by mixed reality and AI. It provides fast and trusted guidance. And as mentioned already, the technology drivers are mixed reality and AI assistance. In this pilot, we used Microsoft HoloLens 2 as the XR interface and large language models provided by the big tech companies. And we will solve the end user problems, which basically comes down to some KPIs that they will need less time to solve the problem. They need less expert guidance, in-person guidance, and they solve problems that have a higher system complexity. So we're not only working on manual machines nowadays. We usually have a software that comes with a machine. We have a touch display. We have integrations all around. So yeah, troubleshooting is way more complex nowadays than it used to be 60 years ago. And this is how we try to tackle these scenarios with an XR and AI-enabled maintenance scenario. Especially for us, it's immersive retrofitting and training of technicians. We provide a mixed reality video call between an expert and a service technician to reduce travel time and in-person presence. We build AI-powered solution for knowledge retrieval and voice commands. And we will showcase some guided workflows inside the XR environment right at the machine to guide technicians through the maintenance and troubleshooting process. Now I think it's the use cases presented by Joshua again.
Yeah, thanks, Matthias. So SCHMIDT HAENSCH as industrial end user of those kinds of technologies, we ask ourselves, how can we improve our service offering? How can we be more efficient and even provide better service? How can we improve the knowledge transfer in between our expert service technicians, but also newer employees or service technicians that are working at a different company where we have a partnership? And also, how can we improve the knowledge transfer from our headquarters to the equipment operator on site? So we defined a few use cases for this project, which we wanted to start with. The first one is the expert maintenance as a service, virtual assistant software to enable remote inspection and maintenance of laboratory instruments through an XR environment. So this is more of a human-to-human interaction. And then the immersive retrofitting to being able to provide remote guidance to site technicians for performing retrofitting tasks. This is also enabled by automated AI systems, so don't necessarily require human-to-human interaction. But we'll showcase that in a demonstration video later, where you see the different scenarios that we looked at. For us, it was important to evaluate different scenarios, technologies for different workflows, and then see where we can create benefit. Our goals for this project were to reduce the on-site maintenance by more than 50%, to decrease the time to complete the task. We always have that little error here in the slide by 25%. And we want to continue to have our 5 scale rating. We do have very good service technicians worldwide, but we need to make sure that with introducing those kind of technologies, we don't introduce any systems that our customers don't enjoy working with. If you move to the next slide, you'll see that we really took the time to analyze who will be working with these technologies that we will introduce to our daily work, and we prioritize them. And the first priority for us was quite clear, quite early on. We want to make sure that service technician experts with more than 5 years of service experience who are located in our headquarters in Berlin or in a service hub. We do have some service hubs all over the world, and who work from a desk with a desktop computer are being enabled to assist field service technicians who are either SCHMIDT & HAENSCH service employees or SCHMIDT & HAENSCH partners who are directly working in the field. They are on site with the asset, and they are working with a mobile device like a laptop, tablet, smartphone, or smart glasses. And we want to make sure that the communication between those two personas is as good as it can get, and use AI and augmented reality technologies to enable this. So this was our first priority. We will see that also in the first scenario of our demo video. Second priority then was to enhance this by introducing an AI co-pilot, because the AI co-pilot, you could understand like a really knowledgeable service technician expert if you train it well. And so the AI co-pilot is almost like the service technician expert, but the AI co-pilot really has access to all service documentation. He can always provide assistance 24/7, and he can communicate to all kind of devices in all kind of languages. So there's really some benefits we can introduce by introducing this AI persona, as we named it. So that was our second priority. And then the third priority was to enhance this even further and make sure that our AI co-pilot would not only communicate to our partners, our service technicians and employees, but even communicate directly to our end customers and the equipment operators. So the people working in a laboratory or the people working in the industrial plant. And yeah, having defined those priorities, and we quickly were able to create user stories and prioritize them. We skipped the user story part here in the webinar because it's a long list of user stories that we defined. But yeah, mainly you'll see that in the demo video that we show later. But for now, I'll give over to Matthias, who will explain what Mindtastic has built based on the requirement analysis that we did together.
Yes, so here you already see 2 screenshots of our AI assistant. And I only depicted 2 details. One shows basically the reasoning process where the AI explains its derivation of information, where it got information from, why it decided to give those instructions, because we're working with black box models which do not tell by itself how the information is retrieved. And the right screenshot basically shows the created step-by-step instructions and the XR training material inside the chat interface. And together with a QR code, this QR code is then used for the HoloLens to scan and open the workflow inside the XR environment. And to come up with such a solution, I will step back a little and talk about the technology drivers behind our AI assistant. There are 4 technology drivers that we use to build. The first driver is a large language model. It understands text, so the technician's input, the technician's intent. It can summarize the context and generate concise explanations and summaries. The second driver is RAG, Retrieval Augmented Generation, which is a new kind of search. It can retrieve data from a big set of PDFs, manuals, everything that is basically plain text can be indexed, stored in a vector database, and then retrieved with the RAG technology within a very short time. And this will help the large language model to collect context, to ground its answers on actual factual correct data and does not hallucinate, which is a big problem with generic LLMs. And the third driver is the speech-to-text model. So we know every smartphone already has some speech-to-text integrated, but with the big AI solution providers like OpenAI and their model called Whisper. And now one AI model can transcribe speech in various languages into very detailed and very correct transcript. So this transcript basically helps to convert the spoken text of the technician into a machine-readable text. And then the fourth driver is text-to-speech, basically the other way around. The text is then spoken back to the technician with text-to-speech AI models. So this allows the technician basically to work hands-free and communicate using language with the AI assistant, which is very helpful in maintenance scenarios because either the hands are oily and dirty or the engineer is wearing gloves. It's hard to navigate through a mobile interface such as a touch screen on a tablet or a mobile phone. So the pipeline we used here is basically the technician starts to speak when he has a request or a query. The speech-to-text model transcribes the text into a machine-readable format. The large language model, together with the RAG and the retrieval-augmented database, here is built upon the company-specific data, like the company's own manuals, the company's old service tickets, or troubleshooting reports, solution reports. Every historical data can be used to populate the knowledge base. And together with this context, it then generates an answer, generates some factual correct workflow or step-by-step instructions. And lastly, this generated text is displayed on the UI and also spoken back to the technician. So he hears it for fast and easy access, and also to audit the answer later on, he can go back onto the mobile device and read through the text. So this is very important to create accessibility, documentation, and auditability, while we keep the technician in control of his action and also still make him accountable for the actions. This is very important because in a maintenance scenario, the AI generated responses always have to be checked. That's where also explainability comes into place. Explainability increases trust into those models because for maintenance, just an answer is not enough. We know it can be hallucinated, it can provide wrong answers. It has from the old training data set and not from the company specific knowledge base. And the assistant, the AI assistant, must show why it recommends something based on the reference it can provide. So we minimize the risk of black box models that they just sound confident, but with a missing context, they hallucinating a procedure, which can also lead to a dangerous situation for the technician. The output has to be explainable. So it will cite manuals, tickets, the checklists it used, or all old history data behind each answer. So this makes the answer grounded on facts and makes it better auditable. And lastly, the human is always in the loop. He has to approve what the AI assistant shows and has to double check it basically before making any operational changes. So from these points, we can derive a trust paradigm. For the technicians, it's important that they are trained to not just trust those AI models because they sound confident. Instead, they should trust only the system when it shows resources, when it shows cited references, and also its limits when it's not sure or does not have enough context to provide a factual, correct, and grounded answer. And to show all those pilot developments in our showcase, we can now start with a video, and Joshua will also say some words after each scenario on how it helped him and his company in their maintenance and onboarding processes.
Welcome to this demonstration of pilot number 2, human-centered remote maintenance and asset management of the XR5.0 EU Horizon project. The goal of pilot number 2 is to optimize service processes at SCHMIDT and HAENSCH. Expert knowledge from service technicians should be utilized as efficiently as possible. The pilot is divided into 2 major use cases: Use Case 2.1, Expert Maintenance as a Service, and Use Case 2.2, Immersive Retrofitting. In all scenarios shown, SCHMIDT and HAENSCH technician Sarah faces the same issue. A varipole polarimeter won't turn on and requires a firmware update. To fix it, she must open the device and replace the internal SD card. As a less experienced technician, Sarah needs guidance to complete the task. Scenario 1 with Sarah and Frank. In Scenario 1, human-to-human remote assistance, Sarah receives support from the experienced service technician Frank Musterman. Frank has been working in SCHMIDT and HAENSCH service for over 25 years. Frank knows the devices inside and out and can assist Sarah with this problem via the intuitive remote assistance platform Oculavis Share. Using the AR video call, Frank guides Sarah through the repair by placing real-time AR annotations in her field of view, helping her complete each step with confidence.
Yeah, Matthias, maybe you can take a quick break here. I hope you can find that spot again in the video so we can continue in a second. So this was scenario 1, and this also corresponds to our priority 1, having a good approach on how our experienced service technicians can directly communicate with the field service technicians and less experienced service technicians of our service partners. With the remote assistance software from Maintastic, this or in this video it's still called Oculavis Share. This enabled us really to be to have our most experienced service technicians in the toughest service work, where they may have to travel for a few days. You need to imagine that our instruments you will find in the last island of the Philippines, where you'll travel at least 4 days to get there, or you would have to have the equipment travel for at least 4 days until they get to our premise. And our equipment is essential for the daily operation of our customers' plants. So often they cannot be offline. We cannot have any downtime with those analytical systems because they are analyzing pretty much all the beverages, all the food, all the pharmaceuticals that we are eating or having to use every day. So this really enabled us really fast to be able to share the knowledge of our most experienced service technicians. Actually, Frank is a real person. He's been working for SCHMIDT HAENSCH for 30 years. Officially, he's already retired, but he's still working in retirement for the company at SCHMIDT HAENSCH. And he has such a big knowledge about our equipment that sometimes can last for 30 to 40 years. And those equipments we manufactured in the before 2000, so in the 80s or 90s. and they're still being used in factories all over the world. And this is really something that is great, that we can be on site and be able to orchestrate service work, which is actually quite complex, and it shouldn't be performed by a not trained service technician, but with the software, remote assistance software like the one from Oculave Share and the augmented reality annotations that we can use in the system, we're actually being able to make sure that we perform the correct service work. If you work in service, you know you can fix a lot, but you can also break a lot. And if you are not instructing the recipient very, very well, and you have the proper tools to instruct them how to fix a problem, you could potentially even harm the system more and break it more than it is already broken. So that was really the easiest of our use cases. We were very fast to introduce this into our processes, very fast to test it in the field. We got great user feedback on that. A big advantages of the system is that we are not dependent on using smart glasses, to be honest, because with this use case, we can simply use a smartphone, we can use a tablet that is augmented reality enabled. And it will already be a big advantage, because we need to be honest, not all our customers do have smart glasses on site, and we cannot always sell smart glasses together with our equipment to be able to perform service in the future. So we need to have a system that is operating multi-platform, so on laptops, smartphones, tablets, and so on. And this remote assistance solution really provided that for SCHMIDT HAENSCH, and we're able to really improve the service we provided and reduce the amount of on-site service tasks that we had to do before, and also reduce the amount of equipment that had to be sent to the SCHMIDT HAENSCH headquarters for in-house service, because we were able to fix the issues with this technological enabler. And I think now we can continue with the second scenario. Here we're now going into a scenario where we are also having more AI in the service work. So we're pretty much taking out Frank. Now it's just Sarah working with the equipment. Of course, here you can see it's staged. This is all done here on premise. But in in the real world, this is how this technology would work. So Matthias, let's have a look.
Co-pilot to human assistance, Sarah receives support from a trained AI that she can communicate with via voice input. The AI uses the SCHMIDT and HAENSCH knowledge database to generate an informative step-by-step guide. Sarah can easily access this guide on the tablet and thus solve the service problem. As Sarah launches the AI Copilot on her tablet, the voice agent shows each diagnostic step it's taking, so Sarah can follow the logic. This explainable AI approach turns a black box model into a transparent partner, coupling GPT-powered reasoning with clear XR visuals to transfer expert knowledge quickly and intuitively. Because the system reveals its chain of thought as tailored decisions, Sarah gains immediate trust in the guidance and can confirm every action before she commits, accelerating the repair while keeping full control. Scenario 3, with Sarah and HoloLens. In Scenario 3,
Okay, so that part of the video was not very fluent for me. I hope it was better for you. In the second scenario, as I said, we took out Frank. We tried to take all the knowledge of Frank, train the AI system with it, and make sure that the equipment operator could directly communicate with the AI and receives a step-by-step instruction on how to solve the issue. And something that we included here, I'm not sure if you were able to see that in the video, but we also introduced the asset management here. As you know, in this webinar, it's not only about the human-centered remote maintenance, but it's also asset management. So the asset management part is that we are able to identify the asset. So in this case, the asset is the laboratory equipment. It does have a specific serial number with the QR code. I will directly forward it towards all the technical documentation of that equipment. So the AI also has the context for that specific equipment and being able then to define a step-by-step instruction. And it was very impressive on how the AI was able to instruct based on the data we used to train it, because the data that we used to train it was not very structured. We used very unstructured data, old PDF files, old Word documents where step-by-step instructions were written down, and we even used emails and so on just to train that AI, and it really showed great potential. And then in the third scenario, we're using the same thing as in scenario 2, but we're introducing mixed reality features and the smart glasses edition, so that the equipment operator can work hands-free and has a more immersive experience when performing the service task, completely alone, only supported by an AI co-pilot and without being actually properly trained.
XR Copilot 2 Human Assistants. Sarah receives support through 3D visualizations that she can access via the Microsoft HoloLens. The visualizations show step-by-step how the problem can be resolved. Sarah begins by scanning the QR code generated by the AI system on her tablet. This QR code acts as a dynamic link to the SCHMIDT HAENSCH knowledge base, launching the corresponding XR workflow and 3D visual assets directly onto the HoloLens interface. Instantly, the device projects spatial overlays onto the real-world Varipol polarimeter in front of her. These holographic guides walk her through the process of opening the device, removing the old SD card, and inserting the firmware update step by step. Each instruction is enriched with contextual metadata and safety warnings, all embedded into the user interface. This improves task clarity and minimizes the risk of errors. Throughout the process, she works hands-free, with visual prompts and check marks that automatically progress as she completes each task. At the end of the workflow, Sarah is prompted to provide feedback directly within the AR interface, rating her experience and noting any usability challenges. This feedback is captured and used to monitor key performance indicators such as user satisfaction, time to complete the task, and system acceptance, enabling continuous improvement of the XR-based support platform.
Yeah, so here in scenario 3, we saw pretty much the last level of AI and mixed reality enabled service procedure, how we imagined it. We have not achieved that state in our daily operation. This is due to hardware limitations that we have here. So we're not able to operate with Microsoft HoloLens equipment all over the world because we simply don't have that equipment on site. There were some drawbacks that come with that hardware, you know, short battery lifetime, you know, dizziness that the operator feels and so on. So here I don't expect us to reach a very high TRL at the end of this project. It was very valuable to gain the insights and also see the limits of technologies for actually being introduced into daily operation. So for us, this was not yet completely enterprise ready, this technology, but it showed a lot of promising results, and we're excited to see how specifically the hardware around mixed reality will develop within the next years, because very surely it does have a lot of potential.
Okay, so I will continue with some more use cases. So as we already saw in the demonstration video, in the pilot, we leveraged some of those technology drivers into some maintenance use cases. But currently we at Maintastic, we are also elaborating on some more use cases that might help the future maintenance technician and service engineer in the field. And this is basically thanks to conversational AI and also agentic behavior, which is a thing in the last year, as you maybe heard of OpenClaw, Hermes, and different agents and how they integrate into a software ecosystem. I will shortly go over them. So one that is already very soon to be shipped feature on our platform itself is a voice to ticket. So it helps the maintenance technician to capture his faults and any solutions hands-free by just using natural voice in any languages. And the ticket is also then automatically structured into the ticket scheme, basically, and also translated in any language the maintenance planner and service admin has set up for the platform. The second use case is, of course, a fast access and a fast knowledge retrieval with a knowledge assistant. It can summarize previous tickets and all the stuff out of the knowledge base. I see I'm missing the subtitle here. The third use case is the workflow generation we also saw in the video. And this can also be done when we think a bit broader, not just creating workflows based on existing maintenance data, but also we can think about a plugin that helps generating and populating the platform with workflows. You upload a PDF and the manuals and or videos, and the AI understands the context of the video, splits it into the most important key sections, and creates a workflow from that video, which is basically multi-step, step-by-step instruction. The fourth use case is a troubleshooting guide, which is similar to the voice-to-voice agent we saw in the video. You can get guidance from the AI agent by communicating in a conversational way. It can suggest next steps and next checks, and also in the end summarizes everything, and then this will lead to use case number 5. It summarizes all the conversation the technician had with the AI and prepares a handoff when a topic or a problem has to be escalated to a specialist. And the last use case is basically the after action documentation. This is, for example, after each week, the technician can ask the AI to summarize all the work orders that were completed, all the troubleshootings that were checked or solved, and basically have the AI to write those knowledge articles to help the company populate the knowledge base with clean and well-written documentation instead of just some bullet points the technician used to add into the platform that in the end nobody really can read. So here we can create very well-drafted knowledge articles. The AI can ask follow-up questions in cases of uncertainty to build a very well-documented knowledge base. And here, as a little advice on how this architecture can look like to keep the AI grounded and trusted with company-specific data. The AI module or the plugin of the AI should happen in the second step, right after the technician interface. So the technician interface is, as you saw in the video, it's basically a mobile app, a microphone. It can be a microphone with a voice input. It can be a QR code that is scanned. It can also be the XR glasses, basically. And The first query, the first voice recording of the technician is then processed by the AI. The AI understands intent. It will populate its context with the intent of the user together with the knowledge retrieved from the vector database with the use of RAG. And with chain of thought and explainable AI safety measures, it will then craft and grounded and well thought out answer for the technician. And this answer is then fed back into the CMMS platform or any other ERP or any other platform basically that handles the assets, the tickets, the specific company, specific data or data histories. And lastly, this is given back to the engineer or to the technician who is in control. That's a human in control. So we close the loop of human in the loop, and the human then approves the generation of the AI, can escalate it to an expert, and is always able to audit the generated output. So here it is important that the human basically stays accountable for the LLM output. Otherwise, we will end up having AI generated rubbish. Now the actual term for that is AI slop. I don't know if you've heard of it. AI work slop. This has to be prevented to be added into the knowledge base because this can have hallucinations included and will thin out relevant information from that knowledge database. And now we come to the survey. Here we want now to collect your perspective on artificial intelligence, mixed reality, and how it will impact the future of maintenance.
Great.
Therefore, Elina will share her screen.
Yes, thank you both for this great presentation. Now I will share my screen to start the survey. Great. Okay, can you see my screen?
Yes.
Great. So now I would like to grab your phone and scan this QR code. And
Christian is having a question. Do we answer questions after the survey or now?
excuse me?
Christian, I see his hand. No, sorry. I saw my own cursor on the wrong name, and it looked like someone was raising the hand, but it was just a cursor of mine.
Okay. Okay, so yes, let's scan this QR code. Here you should check which of these following answers it's better for you. So what is your biggest challenge in maintenance or technical support today? Once you check your answer, please push the button submit in the end of the page. Okay, let's wait a little bit more. Great. So I will move forward now. Where could mixed reality add the most value? Again, here you choose your answer and you press the button submit in the end of the page. Okay, we have 1, 2 answers. Very nice. And we need one more to go to the next slide. Great. Where could AI chatbots create the most value in maintenance? Again, you choose your answer. Great. Okay, we will move forward. What would make you trust an AI chatbot in a maintenance situation? So once you know your answer, you choose, yeah, great. And one more to go. Perfect. Which future scenario feels most realistic in the next 3 to 5 years? That's interesting. Let's see. So again, you choose your answer and you press the button submit. Okay. And the last one, what will define the future of maintenance support? And one more. Great. So that was it, the live survey. Thank you all for your participation. And now it's the Q&A session. So we can discuss whatever you want. You can ask whatever you want. And our experts could answer. Also, you can send a question in the chat. Okay, let's wait a little.
We explained enough, so it's also fine if no one has a
Yeah,
question.
that's true. Okay,
It's
so yeah, if anyone don't have any kind of question, I think that we can end this webinar. So thank you all for your participation. Thank you to our experts for this great presentation that we had. You can find all the relevant materials on the XR5.0 website and on our social media. So yeah, thank you all. Have a great day.
Thank you.
Thank you. Bye.
Thank you. Bye-bye.
Have a nice day.
Bye-bye.
Thank you, Elina, for hosting.